Alright, let's do the other special case, which is perfect squares. What are perfect squares? Well, let's see. It's something that looks like this. How do you expand a perfect square? Well, if you remember, it's like having two brackets that says x plus 3. So basically you'll get x squared, and I'm going to get 3x and 3x, which is 6x. And then you're going to have 3 squared, which is 9. How do you expand this one? Well, 2x times 2x gives me 4x squared. And then you're going to get minus 10x gives me minus 20x. And minus 5 squared is plus 25. So the general term for it, we can clearly see that it's going to be something like this. A squared plus 2ab plus b squared. And you want to remember that one. And of course, if that ends up being a minus, it's a minus b, but that will work on its own. So what do you notice about these three things? Well, there are 3 terms. Also, you've noticed that the first and the last are always perfect square. That's 1, that's 3, that's 2, that's 5, and that's a and that's b. So the first and the last are perfect squares. And the third question you need to ask, it's one that's a little more complicated. Is it the middle term 2ab, i.e., is the middle term twice the first times the second? So this minus 20, is it twice this times this? Well, this is 2x times minus 5 is 10, twice is minus 20. So yes, that's the middle term. And this is 1 and 3. 1 times 3 is 3, double, it's 6. And this is a and b. A times b is ab, double is 2ab. So let's see if we can recognize them from the following examples. Here are my examples. Sorry, that's my questions. And let's look at this first one. So in the first one, we have x squared minus 6x plus 9. Maybe you want to stop it and give this a try on your own, but I'm going to just carry on. So that would be like saying this is just x squared, and this is 3 squared. So now I need to check, is 3 times x twice the middle term? So 3 times x is 3x, twice it's 6. So that means that this should be a minus. So I can just go x and 3 squared, but there should be a minus in the middle. And I'm done. If I wanted to do this by simple trinomials, I could do it too. If I want to do complex trinomials, the method or the trial and error method, that will work too. This one just saved me some time. So what about this one? Well, are there 3 terms? Yes. First and last perfect squares? Yeah, this is 5x and this is 4. So now I need to check if twice 5x times 4 gives me this number. 5 times 4 gives me 20. Twice 20 is 40. This is right. So basically it's 5x plus 4 squared. And I'm done factoring. What about the next one? Well, are there 3 terms? Yes, there are 3 terms. Are they both perfect squares? No, this is not perfect squared. But then I do notice that I can take common factor out. So you're going to have a 2x squared minus 10x plus 25. So I'm going to have 2 and then something. Now, I notice that this is x. That would be 5. 5 times x twice, it's 10. So minus 10, that means I'm going to get x minus 5 squared. And that's going to give me this. Right? And then look for the last one. X squared plus 7x plus 49. So now I have that this would be, are there 3 terms? Yes. Are they both perfect square? Well, that's x, and that would be 7. So now I need to check 7 times x, but twice. This is only 7 times x. So I should see 14x if this was a perfect square. So this is not a perfect square. Now I should try to see if there's another combination that would work, but at least for this point I know that it's not a perfect square and I cannot use that shortcut.